Right, there was the question whether you should open something. So we have a lot of contents to present, so therefore we do not consider this to be an interactive session. Of course, you're welcome to try things, but basically it's a presentation that doesn't mean that you may not ask any questions. Of course you can, but yeah, waiting until everybody followed us on an editor is probably taking too much time. Okay, so I think, yeah, we are nearly 50 people. I guess, Jeffrey, you might start the recording.
Yeah, the recording is on.
All right. So then, welcome to this webinar on basic waterways presented by the training working group of the humanitarian OpenStreetMap team. So who is going to entertain you at this time? I'm Michael. I'm currently the chair of the training working group, and with me are Jeffrey, HOTS community projects lead, and Ralph, the community engagement associate. And so what can you expect in this webinar? We will start with the basic geometry and tagging. There will be something about seasonal waterways. You will get a more in-depth look on tagging afterwards. That will be presented by Jeffrey. Then I'll be back talking about all kinds of man-made waterways, from canals to pipelines, and the important topic of intersections between waterways and highways. And finally, Jeffrey is going to take you through more complex areas such as riverbanks and lakes. As you just heard, this webinar is going to be recorded, and it will be published on HOT's YouTube channel. We'll post a link to that, to those files later on. Just expect maybe a few days of delay for processing. We intend to talk something like 90 minutes all in all, plus leave some time for questions and answers, but we'd like to keep that within something like a 2-hour time frame. You're welcome to type your questions into the chat window. It's the three of us presenting here now. One of us will be talking, and the two others and maybe one or few more people will be lurking in the background and be ready to answer your questions or interrupt the speaker if necessary. So before I hand over to Ralph in order to start with some basic geometry, I'd just like to show you something in here. So stop sharing this one and share just another window, and that would be this one, my JOSM. So okay, does that work? Can you see my JOSM already?
Yes, we can see it.
Okay, so the point when we're talking about waterways, as Ralph is certainly going to explain, these are one-ways. So that means the direction of flow should be the direction of the line. If you're in a relatively flat area, this might be some trouble. If it's in a hilly area, it might be easier. Why is that easier? Simply because we've got some imagery layers which come to our rescue. If you load the imagery preferences, you will see there are a couple of topographic layers, such as the Open Topo Map or also the Open Cycle Map. And So if you move somewhere else where it's a bit more interesting here, and switch to one of those layers, such as the Open Topo Map, and then we just need to move a little bit into some hilly area, and then you can see that it does contain contour lines, so maybe the Open Cycle Map is even better in this area. Okay, now we've got it. So if you zoom in closer, you see that this is a 100-meter line, and so I'm sorry, it didn't select a suitable area before, but that's not a problem. Here you can clearly see that we've got a downward slope, because here we've got a 300-meter line, and so here it is again. So here it's going downward. You see that at the hill shading. The Open Topo Map is also going to indicate that 300, 200, 100. So here it's going downward. So whenever you're not in a completely flat area and don't know the direction of flow, for instance, the Open Cycle Map or the Open Topo Map are usually available worldwide. They might have a little bit of delay because they are hosted on a different server than OpenStreetMap, but in pretty many cases, you can easily see whether it's flowing, where you can see the downhill orientation. And particularly if you see something on an image which you think is a waterway, but then you determine that it's going both up and down, then probably you're in error, and this is just a track. So, and with that, I would like hand over to Ralph, who will guide you through some basic drawing, through a little bit of tagging and things like that. But Ralph, just keep in mind a little bit of tagging, because Jeffrey will be next with a more in-depth look then at tagging. And with that, yeah, Ralph, it's your turn now.
Right. Thank you, Michael. I'm going to try and share my screen and see whether this works. Right.
Yep. The presentation is visible. Yes. Thanks.
Okay, great. Let's just see. Put it a bit bigger. There we go. Right. Okay, folks. As Michael was saying, today we're going to look at water features. We don't get a lot of demand in hot activations and missing maps for water features, but the water features are quite important. So the one thing, to be able to draw water features, you have to have an understanding of waterways. And that understanding is quite important, as you will see as we go along, for the reasons that it's not quite as simple as drawing buildings. The proper idea is that waterways should have a specific way of drawing them. So let's just go ahead. So let's have a look at what I will be showing you, so that you know in advance as we go what is still coming. I will be showing you some basic rules about waterways, followed by basic drawing, understanding the direction of flow, what main channels and tributaries are, and also what is seasonal and intermittent. Right. moving on. So let's start with some of the basic rules, which are important. Okay. First of all, understand water flows downhill. As Michael was explaining with the contours, it flows downhill, and the downhill direction is the direction of flow. And this simple fact should be applied to all rivers and streams. Next one, waterways cross highways in 3 different ways: a bridge on the highway, a tunnel culvert on the waterway, and a ford. But Geoffrey will be speaking to you more about this later, so we'll move on, but that's the main 3 ways. Okay, now there's one highway difference. When a path crosses a waterway, it should share a tag with the waterway unless it's on a bridge or in a tunnel. The reason for this is there's many different ways of a person on foot crossing a waterway. They can either use stepping stones, they can wade through the water, or they can swim across. So we don't show any of those. We just connect it to the waterway and to say that this path can cross this waterway at this point.
Ralph, excuse me, would you want to say share a tag or share a node?
Share a node.
Okay.
Sorry, share a node. Right. And one very, very important one, which I want you to note as you come across, is waterways do not have a layer -1 tag applied to its length. This is wrong. This tag should only apply to the waterway culvert or underground tunnel pipeline. It should not be along the full length of the waterway. So please, this should not happen. If you do see that and remove the layer -1 tag, you then need to run your JOSM validator, because what will happen is all along the way of that waterway, you will then find that the highway waterway crossings will all be incorrect, because the JOSM wasn't showing them before, because the layer -1 tag was blocking it by saying the water doesn't cross the road. So that is something you will need to check if you do remove the -1 tag. Thank you. Right, and lastly, sometimes a waterway does not flow into another river or water feature. It just seems to disappear into a wetland or disappear into sand. When this happens, the node at the point where the waterway soaks into the ground is tagged with waterway equals soak hole. Now that is not appearing on some of the documentation, but this has been approved, and that is the way that you would end it if it can't continue anymore. So waterway equals soak hole, where a waterway dissipates into the sand or wetland. Right. And some waterways do not always have water in them, and these are tagged as intermittent yes. This should be used as the default when the flow of water is unpredictable. In other words, you don't know when it will or won't be water in the stream or river. Next, when the flow of water occurs every year at the same time, then the tag is not intermittent, it becomes seasonal, yes. But it only used if you know this for a fact. I've given an example there. When snow on a mountain melts at the beginning of summer, when the weather starts to warm up, this would happen every year as long as there's snow on the mountain. So if that is a regular occurrence, then that is seasonal. But don't use seasonal if you do not know this for a fact. Rather use intermittent. Right. Now let's just see whether I can change my screen, and we're going to go to drawing. Let's just see. Right, here's an area that I've picked up from Mozambique. Sorry, Madagascar. My apologies, Madagascar. And I'm going to use Bing imagery here. Right, now I've chosen this imagery in this area because it very, very clearly explains what we need to be doing and how we need to be doing it. The problem is that this kind of clarity is not always common throughout with the imagery. In some cases, the vegetation is so thick that you cannot see the waterways, or it's blurry, or it's unclear. However, I need to clearly explain to you what is happening. Now, first of all, we will only maybe get a small square in our task, and then we just see something like this in our task with no bigger picture. Well, what I need you to do is to understand the bigger picture. So close off your mapping layer and zoom out to have a look at the imagery, and you then have a look at where there is a large waterway, and does your piece of waterway flow into that? If so, this will give you an idea of the direction of flow. Now, direction of flow, I already said, is downhill, and the waterways, unlike highways, need to have this direction of flow. Now, when we are drawing, we must understand what is the main channel. In other words, the long waterway, which goes all the way down through everything into the main waterway. And that channel, main channel, is the one that you need to identify. All of these other waterways that are flowing into it are tributaries that add to and fill. Now, the one thing that we don't want is when people start at the end point of a waterway. Now here, it's very clear. The waterway starts here and flows down that way. The waterway starts here and flows down that way. This waterway flows down that way. And this is the ridge of the hill or mountain. The waterway should not go over the top and back down. And if it's all running along the ridge of the waterway or across the contouring, then that is a road, it's not a waterway. Now, drawing waterways, you shouldn't zoom in too far, just enough to be identify where the waterway is. The reason for this is pretty clear. The more you zoom in, the more you have to add extra nodes and little kinks and turns and that. So what we need to generalize a bit, because we're trying to be conservative in the number of nodes we use, but not to the detriment of accuracy. Just remember, the more nodes on OpenStreetMap, the bigger a server we need to be able to store them. So we try to be conservative with nodes. Right, so starting off on mapping, press A on the keyboard for your line tool. That's in JOSM. In ID, you would choose the line tool for doing your work. Now, all you need to do is to start where you think the waterway starts and keep mapping along its length. Now, you can see I'm not doing all of the twists and turns. I'm doing some of them and long straights. Now I zoom out to try and see what is happening here, and it looks like the waterway comes down here and joins into the main one. Now we have a problem because too many people start like this and continue on down the main channel. Okay, now select add waterway and I want that as stream. Okay, right. So I've got the stream there. Now that is wrong, because in actual fact, this should be continuous along its length. So this is what I call doglegging. Okay, and that is not very good. When a tributary, remember I've talked about main channel and tributary. When a tributary reaches a main channel, that should be the end of the tributary. So I pressed P on my keyboard to make that now the main channel, Shift A, and I can go backwards. Okay, now there are little arrows as you draw. You can see there are little arrows here on the line of the waterway, and that indicates direction of flow. It's important to keep those and to make sure they go in the correct direction. The way to change one, if you see that they are in the wrong direction, is simply to press R on your keyboard, Josim, and it will ask you, do you want to reverse the river? You say yes, and you will see now that the arrows go in the opposite direction. So that is how you reverse. So I'm going to reverse back again. Okay, so change direction of flow. In ID, try to draw the waterway in its direction of flow right from the start. Then you won't have the problem of trying to change or alter them. When a river reaches a wider point, of course, there is a different way of dealing with that, but I'll show you that later. Now, so at this stage, we are looking at this. A waterway can start from the top here. Now, if you've got quite a steep run like this, is very obvious, very steep, and you can see the erosion here. Now, what happens in very steep runs like this is the water flows off very quickly. So a stream coming from a very mountainous area into the main one may very well be intermittent. And you could show it that. If the area is very, very flat, then this is not actually the case, because water then flows off rather slowly. So do not use intermittent for that. If you can clearly see that the waterway you're trying to draw has no water in it whatsoever, and this can be very obvious in dry areas like the Sahara Desert, in the outback of Australia. So in places like that, yes, intermittent rivers will exist quite commonly. But in most cases, you will find that if you zoom in, you can see that there is water in here, and then a rocky outcrop and some more water and rocky outcrop. So there is water in this stream, sorry, this river. And that is something that we need to consider, right? So when we continue our stream, I press A on my keyboard for Josim, and I get started again, and I am just using long straights, and oops, there we have a ford with a footpath crossing, so it must share a node. I've done that, and I come here. Now I see that this widens. Now, I've done something here. I've joined this with a node, but when I check that, it is actually a ford, yes, and the ford is across the river, so it's quite a wide river, and the ford goes across. Now, you didn't see the little tractor thing that showed that, the little arrow thing that showed a ford, but be careful, that may still be a ford, and it needs to have a node, okay? Right, so I carry on to the water. Now, too often, what we find is that they end the river at the water, the edge of the riverbanks. This is incorrect, and the main stream should not connect to the riverbank. It should continue across into the river and join the river in its direction of flow. Okay, so now there we have it. do not connect the river to the riverbank. Please continue it on into the middle section where the river flow is. Now, this section here, if it's wider than 10 meters, let me do A on my keyboard and measure this, right? And I see that 16 meters wide. Let me get rid of that. Right, so that's 60 meters wide. So this would warrant having a riverbank shown as well along this section here. And that I will show you at later on. So now you know how to connect. If you have a lake along the way of the river, then this main center channel should actually cross the lake and out the other side, or connect up with other waterways coming into the lake. So that is important because for navigation purposes and direction of flow, so that is continuous. Right, now that has given you some idea of drawing waterways and a little bit of understanding and of what they are about. Please remember the rules and understand that you have to look for the long channel and then add the tributaries to the long channel. Direction of flow is important. Okay, I'm going to pass back now to Geoffrey, who is going to talk to you about tagging. So I'll stop sharing my screen. And back to you, Michael and Geoffrey.
Thank you, Ralph. I'll just go ahead and share my screen. So I'm going to talk briefly about the basic waterways or tags that we use for waterways, and I'm going to focus on natural waterways for the start, because we have like some waterways that are artificial, but also have some that are natural. So starting with rivers and streams. So I think the main important thing when mapping waterways is for you to clearly determine what is a river and what's not a river, because it would not be right to tag like a small stream and you tag it as a river, or a ditch and then you tag it as a river. So the river tag should be used in the right way. What we call a river when we're doing mapping in OpenStreetMap is really a natural flowing watercourse. Usually it's fresh water, usually flowing towards a lake, an ocean, a sea, and sometimes rivers also flow into other rivers. The main tag we use for a river is waterway equals river, and that is for the linear way. And then if we are mapping, so there are some rivers which are big, which are like wide enough, and so they require mapping of the area of the river as an area. So like you can see in this image, so the river is really like big. It's like a big body of water, and it has been mapped as an area, but also it has like ways that cross through it. So in this case, then we tag the river, we tag it as water equals river. The other one is a stream, and a stream is a naturally forming waterway that is too narrow to be classified as a river. So what really differentiates a river from a stream is the size. And I think the best kind of definition or criteria that you can use is if you can cross it with like just by walking. So you don't need like a river to cross the stream, you know, you can just walk through it and you're on the other side. That can be like the best guidance that can help you to identify that this is actually a stream. So the tag that we use for streams is waterway equals stream. But also we have some additional tags that can also be used on these waterways. Even for rivers, we always need to specify the name using the name tag. We can also specify the width and also whether it is a permanent stream or a permanent river, then we can use that tag, which is intermittent. So it is intermittent, yes, that means that section is seasonal. And you may note that it might be a long river and some sections are permanent, but some sections are seasonal. So you can also like indicate the intermittent tag. If it has like a permanent flow, you use the intermittent tag. But for seasonal, then we can tag like certain sections as seasonal with the seasonal yes tag. Now, one other tag which is very, very common when you are mapping waterways is the layer tag. So if you are mapping a river, but a particular part of that river is going under a road, then you can tag that section that goes under a road as a layer -1, and this is usually joined with the tag of tunnel equals culvert. So there is a tunnel or culvert where the river is flowing through, and once you have added the culvert, then you also add layer -1, meaning that the river is actually flowing under a road through the culvert. Okay, so those are kind of like the basic tags that you would use when you are mapping a river or when you're mapping a stream. And I'll just briefly just switch to my JOSM here. I've already downloaded some areas here that we can look at. One thing that is very, very helpful when you are mapping waterways is to use your filters. So yeah, I've added this waterway equals asterisk kind of filter. And using this, I can easily, you know, look at only the waterways and hide other features. So yeah, this helps you when you are mapping waterways, because then you can just focus on looking on in the feature that you are interested in. And if I go ahead and select my feature here, I can see the tags here in JOSM. So this is the Sezibwa River. That is the name, but also you can see there is kind of an alternative name. So some people use double S on this river name, other people use single S. So all of these different alternatives have been added just to confirm that this is actually the same river. Also, you may find like some rivers are long and they're given different names in different sections of the river. So that's also the other thing to be mindful about, because rivers normally connect to each other and normally flow into a bigger body of water, but sometimes they are called different names in the different sections. You can also see an additional tag here, which is Wikipedia. So if it's a big river and it has like an article on Wikipedia, sometimes it's useful also to add the Wikipedia tag. So basically, you would go to Wikipedia, you search if that river is there, and then you add it as a tag here. This is very useful if someone is, you know, looking at the river in OpenStreetMap. They can easily read about it on Wikipedia as well. So that's how the Wikipedia tag can be useful. Yeah, also have another example here of a stream. So we can see here this stream is waterway stream, and I'm going to add like the imagery layer just for you to see how it looks like. So it is a small stream coming here, and it is flowing into a river. So one thing you'll observe, and just to show you which river this is it is the River Nile, that big and long river which starts from Uganda and flows all the way into into the Mediterranean Sea through Egypt. So this is the river here, and you can see from the imagery that I was showing on the slides, this river, because it is big here, can also be drawn as an area, and meaning that if it's drawn as an area, then this river can be connected to the river. But when you look at it now, if I remove the imagery, you may think that this river is actually not connected to the river. So there are two ways how I can fix that issue. I can either draw the river as an area here, so that the stream powers into the river. The other way would be just to connect this and extend it to the river so that they are connected, because we can clearly see that this stream is actually powering into the big river. Yeah, so basically that's those are like the best tags we use for rivers and streams. Yeah, I'll hand over back to Michael now, but I'll come back later to talk about lakes, ponds, and reservoirs. So for now, back to you, Michael.
So thank you, Jeffrey. And yes, so I'll be continuing now, talking something about man-made waterways. But before getting back to JOSM, let me just share my screen here. There is often a question: how can we get tagging right? And so the definitive resource here is the OpenStreetMap wiki, and there is a page called Map Features, and that is generally, oh, one moment, please. Okay, yeah, that's working. Sorry for that interruption. So the map features is what is generally acknowledged. And scrolling through here, you can see that there is hardly any category which is not covered. And yeah, of course, there is also one about waterways. We have the natural causes, which have been explained in detail. And now we've got man-made waterways. So that means mainly we talk about the first three categories. There is a canal, which is an artificial open waterway and can serve many purposes. In particular, there are basically just two different tags here, the drain and the ditch, which are used for drainage, thus carrying water away. That's important to keep that in mind. A canal is an artificial waterway irrespective of its width. The only thing is, if it just serves the purpose of carrying water away, then it's not a canal, but a drain or a ditch. Even if you are in an area with irrigated agricultural fields, no matter how small that canal is, it is a canal. The difference between drain and ditch, well, whether it's lined with concrete or not, might often be difficult to see from aerial imagery. But yeah, if in doubt, map it as a drain. So the difference here is really just the lineage with concrete or nothing. That's not that important in our case. what is also, yeah, this is for waterways, for man-made waterways up in the open. We've got a couple of other bits here. So if the waterway flows above ground, then it would be an aqueduct. And if it flows below the ground, then it will be a pipeline, a culvert, or a tunnel. I'll talk about the differences soon. So having been introducing this here, I have to get back to my JOSM window, JOSM, and share that. And yeah, so this is an area where we've got all kinds of these waterways here discussed so far. So let me just show you the picture here, the imagery here without data. We've got the large one here. The large one here is clearly a river. That here might also be a river, but in fact it is a canal. It's man-made. Usually that might require local knowledge, but yeah, if you can see something like such a lock in here, this is certainly one indicator, a good indicator that it is a canal and not a river. Also, canals usually tend to have an equal width over the whole of their lengths, whereas the river, well, as nature puts it here, has a varying width usually. So, and then we've got all kinds of drainage here because that is an absolutely flat landscape. It's from the northernmost part of Germany. And so these artificial waterways here, they're all used for drainage. And so this one, which is a bit larger, that's a ditch. And the smaller ones here are mapped as drains. Might also be a good indicator how to map these and how to tag these properly. And of course, direction of flow here needs to be somehow consistent. That means, of course, drainage means the water has to go into some other reservoir, usually a canal or a river. So that makes it pretty clear that this here is not mapped properly because the water is not supposed to flow away from the river, but into the river. So that's not as we'd like to see it. The others are obviously mapped correct. Yeah, so the author which mapped this one here was not very consistent. So yeah, we should try to keep an eye on consistency here in the direction of flow. As I said, if we had an aqueduct, then this is definitely some artificial waterway above ground. I'm coming back to culverts and quite soon. Now we've seen those natural waterways. We've seen here a couple of artificial waterways from the canal to those ditches and drains. And yeah, we've already learned that layer tag is something important. And I'd like to show you a different area here where we've got a couple of problems in this respect. And in order to reduce things a little bit, I'm applying a filter. That means we only want to see waterways and highways. That makes things easier. And then there is something else in JOSM. So this is an excerpt from the port of Hamburg in northern Germany. And well, you can see, of course, there's a big river. Yeah, that's the Elbe. You've got smaller rivers, and also that's a canal. You've got highway bridges which run across those canals here, and you see that something here is highlighted mysteriously in red. So the reason for that is there is a very interesting map paint style which I can highly recommend, and that is Inline Validation. It's part of the standard, so you can find it on the options. So if you go to F12 and then to the plugin tab, you can find the Inline Validation tab. Inline validation means that it highlights all sorts of problems it can find. So for instance, missing layer or wrong value. What's the point here? So these are some kind of, let me switch the filter off. So these here are man-made piers. They are floating and they are connected by a bridge. Well, someone thought it would be a bridge, but unfortunately, the layer tag is missing. So this ought to be a bridge with layer equals 1. I think it's pretty much the same what we see in here. Yes, bridge equals yes plus no layer. That simply isn't what we'd like to see. This can, by the way, this inline validation map paint style will also highlight something like overlapping buildings. So it's pretty useful in a general sense. Missing layer or wrong value. What's going on here? Oh, we've got a bridge with layer -2. So kind of a subterranean bridge. I mean, please don't do things like that. What is probably the intention? So let's switch off the data layer so that we can have a closer look. Okay, so we've got the surface of the Earth here because that's where the water is. And the layers, of course, are always based on that. Layer 0, which is omitted because it's the default, is the surface of the Earth. Anything above ground gets a positive layer number. Anything below ground, a negative one. This walkway here is most definitely not below ground. So I think what the intention was here is those bridges were mapped first. And as could be expected, someone assigned a layer equal to 1 because it's above ground. Then someone mapped this pedestrian, this walkway here, and figured that it's below the bridge. Didn't quite know what to do. Well, what you ought to do in here is, of course, we have a vertical stack. The water is lowest. This walkway here comes next, and the bridge final. So take those ways on the bridge and change layer from 1 to 2. And then you can assign layer 1 to this footway, and you're good. Okay, there it changed into -1. Not quite sure if one can call that subterranean. You'd have to, well, check on the ground whether it's really underground, but I suppose that it still is above the water below that bridge. So I'd rather continue using layer equals 1 for this footway here, and then change the layers for all those bridges here from 1 to 2. So simply keep that in mind. Yeah, we've got, and there is, by the way, no reason to assign -2 to anything here if there is no -1. So just be consistent and have a consistent stack of layers below and above ground. Sometimes I've seen a bridge labeled layer equals 11.5. That doesn't make sense anyway, because it's just a vertical ordering. We've got simple numbers, integer numbers here, which designate positive and negative, which designate the relative ordering. Layers have absolutely nothing to do with an altitude in meters, so don't try to use a very high layer number to indicate that a bridge is particularly high. So yeah, we've seen that these are cases where we'd really like to avoid the direct intersection. The point is, how can we easily map such intersections of highways and waterways? Let me take you to another continent. There we are. That here is from southern Vietnam. We're in the Mekong Delta where rice is grown. And so we see someone mapped this unclassified highway. And yeah, we've got more than enough water around to see what we can do here and try something. So first of all, also well, what was it? Just being a little bit better. Yeah, a little bit clearer in this case. We see clearly the shadow here, so this most definitely is a bridge. And so that would mean, and these are obviously canals. They feed water into all those different basins. So first of all, you would start, for instance, drawing a waterway like this. And so using the canal, because it's probably artificial. And now, as this is a bridge, we have to put a bridge onto the highway. Of course, the standard way would be you go to the add mode here and double click here and double click there, and then you have to select both points and together with the highway. And after all these three objects are separated here, then you go to split away at the selected node or simply hit P. Let the longest segment reuse the history. And then you have to select only the bridge. And then you can add relevant layers. You can add them directly. Certainly better to do that in here. Say we've got a bridge. We've got layer equals 1. And then you're done. It's quite a bit of work. There is an interesting plugin which can simplify things for you. So let's just revert that. Now we've got the highway as it was mapped previously. There is a plugin. Let me just show you. F12 gets you to the preferences, and we've got the plugins, and looking at my installed ones here. Then we've got the PT Assistant. The PT Assistant, this abbreviation stands for public transport, was well developed for public transport people. It's got a couple of features, but not only for public transport, because it's got a split tool for layers. So if you install that, you just have to keep in mind that it will also automatically install an additional paint style suitable for public transport and also activate that. So if you see something weird afterwards, just go to the paint styles tab here and deactivate the one for public transport. What it does make as well is that it adds another icon here. It's the double split icon. And that means with that icon activated, I just have to mark the 2 points where I want to split that highway. One in here, simple click is enough in this mode, one in here, and then it asks me what I want to do. I can generate a bridge, I can generate a tunnel. Yes, and the other two, of course, are for public transport mapping. So in this case, of course, let's call it a bridge. Bridge, yes. Okay. And it does not only add the bridge, it automatically adds a layer equals 1, which will be sufficient in most cases. So if you've got to do that more often, you will find that a really useful tool, because it just reduces the number of clicks here to 2, plus then, of course, selecting the appropriate tags. But even that is easier because you don't have to care about the layer in such a simple configuration. And it also works the other way around. So in this situation, we have a canal which passes here below that road, and that certainly doesn't qualify for a bridge. I'd call this a culvert. So let me first get back to the draw node mode and add something here for this canal, and it would join the other canal down here. So once again, it's a canal. This time, we do not consider it a bridge. We think a culvert will do. Again, you can use this double split tool. Say the culvert will extend from here to here. Yeah, and as I was doing this on a waterway, it automatically assumes I'm going to map a tunnel. So that's a really clever tool. I could, of course, manually change anything. And it adds layer -1, even easier here in this case now. I'm starting to love that tool. So the important point is now, let me get back to the wiki. And share the wiki again, and the map features. So we have so you can also simply look for culvert. That's not proper here. Okay, let's go for the tunnel. Okay, let's look here at the tunnel. And looking at a tunnel, we've got the culvert. The point is, it's just for waterways which pass under a road. And if it would be something only strongly emphasize, stick to the wiki, and you've got more information, you've got more examples like this one here. Tunnels below, all kinds of highways, smaller tunnels, they are culverts. If you are in doubt whether some advice here is really appropriate or not, I also encourage you to have a look at the discussion page, because first of all, if you would like to suggest an amendment, that's the place to go, but others might have been discussing at that point already. So culvert versus tunnel, or food, yes, appropriate here, some other controversies. So it might also be really pay to have a look at this discussion page and see if any of your problems or questions has already been discussed there. If not, you're welcome to open a discussion here. So to summarize here what I've been, oops, sorry. I need my presentation. because, yeah, I've got a quick summary here of these artificial waterways. So if it's on the ground, it is, first of all, in most cases, a canal. Map it as a drain or ditch only if it's used for drainage. If it's above ground, then it will be an aqueduct. If it's below ground, it would be a culvert if it's passing under a highway, a flooded tunnel in most other cases, well, and a pipeline, of course, only if it's really a tube. So, okay, yep. And yeah, there's, of course, a third way of highways intersecting with waterways. We not only have tunnels and bridges, but as Ralph already explained, there are also fords. And so, for instance, when you've got a path intersecting with a highway, you will very often encounter a ford. And I also recommend having a look at the wiki page, because there are also some additional parameters. For instance, there might be stepping stones in a path ford, which make it easier for you to cross if there is at least a little bit of water. And in many countries where hot is mapping, fords are pretty common. You should only assume that a highway uses a bridge to cross a waterway when you clearly see it, because in humanitarian project, it makes a difference. If the crossing is a ford, that can pretty often mean that in a rainy season, this is not the way to go, because you won't get through. A bridge should get you to the other side of that waterway almost all year round. And yes, with that, I would like to go back and let Ralph continue with wide waterways, riverbanks, and multi-polycons. And finally, Jeffrey then would talk about lakes, ponds, and dams. So over to you, Ralph, now.
Right. Thank you, Michael. Start my screen. Yay. I love it when things happen correctly. Right. So, let's just try and make it bigger. Come on, come on. Okay. Not happening. Okay, right. We're going to use yeah, it did happen. Okay, sorry about the slow. I will have to watch that. If it's too slow, I need to talk slowly. Right, so we're going to talk about wide rivers. One of the things that I want you to be perfectly clear on when you're doing wide rivers is to understand that in many cases, the edge of the water that you're seeing may not be the edge of the water. In many cases, the trees actually overhang the water, and the edge of the river is a bit further back. So I want you to bear this in mind. This is quite important when you're doing the drawing. And now, another thing with wide waterways is that some of the features can be really problematic. We will cover this more in an advanced waterway training seminar, but the biggest problem facing us is that they're not static, they're mobile, they keep changing. They have floods, they have droughts, they change their waterway channel or widen it, and then it goes shallow again. In some cases, it's predictable when this happens, and the local people actually put farmland onto the floodplain, and grow crops and everything, and then wait for the next flood to wash all that away and start again. So that's something that you need to bear in mind. The next thing, of course, is to understand that imagery, it can be in different seasons. It can be in dry season. It can be in a wet season. So when we come across a dam or a lake or something that's drawn that is much bigger than the actual water that you can see here, please don't change that all the way down to just what the water you see. You have to bear in mind that when you draw these, you have to put it at the high water level and not at the low water level. And also understanding where things flood, right? I'm going to show you something. Don't be frightened by this, but it is an example of what you can expect when you are seeing wide waterways. Let's just see if this happens slowly. Come on. Okay, right. I hope that this will work. It's not working. There we go. It is. Right. Go back. Sorry that this seems to be really slow at the moment. I do apologize. Right. I want you to watch this. This is something that I managed to capture and find. So if it is, this is not happening the way I want it. Sorry, guys. Okay, this embedded video does not want to work properly. I apologize for that. And my video is very slow. This waterway keeps changing because it floods regularly. And let's just see. Yes, there we go. It's working now. You can see that over the years, this has changed drastically and dramatically, and just keeps on changing as it floods and dries up and floods again. And the main channel, you can see how the main channel keeps on changing as well. So this is something that we must bear in mind when we're dealing with this sort of thing. It's not always ideal for what we are trying to do. So that's my slideshow. I'm going to see if I can get this down now. Right, so drawing these waterways. Let's just see if I can do that. Right, here we are. I've selected this area. Let's just get my imagery in so we know what we're talking about. Bing. Okay, once again, we're in Madagascar, and you can see very clear channels, and we have a wide waterway. Now, remember, Michael told you a natural waterway changes size all along its length, and you can see that very clearly here. Definitely a natural waterway. Now, when we start to do this, it's okay, right. So in a waterway like this, you use your line tool. You've got your channel down the center, and you use your line tool along the riverbanks. I can see here that I can see land, and then shrubs, and then land, and then shrubs, and land again, and land again. This gives me some idea of the water bank. So I can do something like this, right? I use my line tool, and I keep generalize. Now, go over to the other side, and I follow the line down the other side. And cross over. Now, what happens is that it links to the other and forms a polygon. So press S on my keyboard. I now have a polygon. Direction of flow is not important here. There is no direction of flow. Now, for tagging of this wide river, you are going to come into a bit of confusion. So let me just introduce you to the map features page, right? The old way of tagging this was waterway equals riverbank. That was it. However, this tag has been largely been replaced now by two tags. One is natural equals water plus water equals river or water equals stream. So that is the new norm. Two tags, natural equals water and water equals river. So we're no longer using riverbank. Okay, let's get rid of that for the moment. Now, so we have now got to add the tags. Waterway. So this will be not waterway river, but natural and water. So natural equals water, okay. And then we add another tag, which is water equals river. Okay. Okay, now that's a section of wide. Now, what I want you to remember.
Sorry, Ralph, you said water equals river as the key. You wanted to say water as key and river as value, I think. It looks strange now.
Okay, sorry. Edit. Water equals river. Okay. Okay, there. So thanks, Michael. Water equals river. So you get this. Now, what you would need to do, because things change along the way, and that is a single polygon. Now you can extend a single polygon quite easily just by grabbing the little plus sign and moving it along. So you can extend the length of that. However, because we want to add certain features along its way, like this. We have here a split with a piece of land in the middle of the waterway and a piece of land here. Now, this is interesting. The river is shown running across this. This is incorrect and would need to be changed if you're adding your wide river. So what you need to do is to take the main channel around the river, around the piece of land, so that it avoids. And what the result is, it won't interfere in what you're going to do. Where you have extra sections, you would add more river. So you would add an extra piece there, select, add waterway equals river. Okay. Now the name will run across there, so you don't need to worry about that. To create this, press A on the keyboard. Now you need to be careful here. This could be just a flood channel. In other words, when the waterway is full, that is there, and when the waterway is not full, that might be dry. So have a look carefully and make a decision whether this is an island or whether it's a piece of land and that just dry intermittent flows through. If I chose to include that as an island, then I would use this as the bank of the river. Okay, I'll show you how this links up. And I go down the other side and connect up. Select, add natural water, okay, and add water equals river. Okay, so now I have that. Now what do I do with this in the middle here? Okay, I use my line tool, press A on my keyboard, and then I go around the outline of this piece of land in the middle here. Select that. Now, I want this to be separate from the river. I don't want it to be identified as the river. So I would add this as a place, and the place equals islet. Islet is a small little island in the river and should not be confused with proper islands like Australia, the United Kingdom, and that sort of thing. Sorry, like Great Britain. Island, those are all islands, the Isle of Wight. So okay, so now I have this is a place islet. So I select that. I select the outline of the river, which is my natural equals water, and then I use my tools, create multi-polygon or Control B. And I then have an islet appearing in the middle of the water, with water around it, but land in the middle. So I can do that again here. I press A on my keyboard and I start this. Right, I select that and I add the tag another place islet. Okay, now I want to add that to my multi-polygon. So I've got that selected. I hold Shift key on my keyboard using JOSN. I select the outline again and I go up to my tools and I have update multi-polygon. So Control Shift B. And I update the multi-polygon, and now both of those are an island in the same area. This is the correct way of doing that. I want to see whether I have an example. No, okay, not readily available. Okay, yes. Let me just continue this, then I'll show you an example. How does this link up to that? When you are drawing, let's just take us back and get rid of that. Okay. Right, so I'm going to continue this. So I use my A tool, A, and I take it across and I click on the node of the previous polygon. I take it straight across and I click on the node on the other side of the previous polygon and I connect it back up to my polygon, and there we have it, right? Now I do this, I section this so that it's really difficult when it comes to changing multi-polygons and identifying multi-polygons. So if you keep it close together, the person can see all of the pieces of the multi-polygon, and that is useful. If you have a multi-polygon that goes all the way up the river and creates another islet here and another little islet over here, then the person is not going to know all the components of the multi-polygon just by looking. And here is what a problem we have. And I want you to be very careful about this. Multi-polygons are not locked. All the features together are not locked. So you can take a multi-polygon and you can move it. And the multi-polygon can move and the islets stay where they are. So not all of the components of a multi-polygon will move with the multi-polygon. And you have to be careful if you want to move it. If you want to move it, you have to select all of the components and move it. Okay? Remember that, especially also when you are working with buildings that have a courtyard in the middle. So you've got a multi-polygon building. Make sure that you actually grab all of the components of the multi-polygon when you move it. Okay, right. So now we've got that. I want to, then you will continue on the other side with your line tool and click up here and continue drawing the right. Select, add natural water, okay, and add water. Let's just do it. Water, river. Okay, right. So now we've got it linked up and it carries on and continues along the river, right? We can see here again, we have a main channel and we have some small islets here. So we would do the same there, okay? Now I drew this, but I can see here that there's a little water channel that goes through like that. Now that I'm not showing as part of the river because it's completely dry and this is through. However, on a wet season, there is possibly the chance that there is some water that flows around this little piece of land down here. We don't show that because that may or may not happen, and it's not continuous. Now, in very, very dry areas, you can add intermittent or seasonal to that outline as well. Okay, the main water channel may be a continuous flow, but the wide riverbank may be seasonal. That is a possibility. So that is something that you need to have some local knowledge to be able to do. However, if the main channel is intermittent, then the river bank should also be intermittent. Okay, and as I said before, any tributaries or streams or rivers that are coming in do not connect to the riverbank, they connect to the main channel. All the names and directional flow and navigational data and things like that will be on the main channel, and you don't put a name on the natural water riverbank. Okay. Okay, now oh yes, I was going to show you let's just stop this and show you this one. Right. Why I want to show you this one is quite important. This is what people do when they don't understand multi-polygons. What has happened here is you can see here the join is up to the point there, up to this point here, and up to that point there, and then they continue it there. Now, what they've done is they've created holes. Let's just see. They've created these holes in the river so that it doesn't fill up with water. But that's incorrect, because what they have done now is, while they've created holes, they haven't identified those holes. That does not automatically become a place islet. And that is not very good mapping. Okay. Also, what I want you to see is how much this has changed since the previous mapping. We can see here how much this has changed and how much the flow has changed. We can see this, all this big section here shows that flooding has washed away all the vegetation there. But on this side, it has stayed pretty normal. Okay, there's another section where flooding has taken away. Now, remember I showed you the changing waterway. Now, here's a prime example of that, and how much of the flooding has actually washed away vegetation and changed the riverbank from what it previously was. So we can see here that this now is land use farmland, but that was the old riverbank, and we can see here water channels running through here and down here, which is outside the level of this waterway. So yeah, that is quite an interesting fact. Another one that I want to show you. Have I got it here? Right, this dam, full or not full, okay? Let's ignore what is happening there. Let's just look at the imagery. So here we have the imagery, and we can see that this is quite full, but I can see various lines here which indicate original or previous water levels. So I can see that on this imagery. This imagery show tile info, and this is 2014 to 2022. So I'm not quite sure which is the latest and which is not the latest, but I can check that on ID editor. Now let's just have a look at other imagery. Let's go to Esri. Now here's an example where imagery has been patched together, and we have different times and different years. All of a sudden now this part is full of water, okay? And this part is quite shallow, and that is full of water. Now these are, I can see here, this has been patched in, that has been patched in, and that is the original previous that you were seeing on Bing. So that's a low level mark. This shows a higher level mark, and that shows an even higher level mark, which makes it very difficult. And the only way that we can try to map this is to use the high watermark or switch between imageries to make sure we know what we're doing. Here you've got, if I show you the original drawing, this does not even indicate that the water can still go out even further. So you can see that different years will show different levels of water. And please stick to the high level mark and not keep changing it to show what is happening. So this is a prime example where a number of patches have indicated the different levels of water. This is a problem that we have, and understanding that and looking for the correct way to depict a large area of water is of paramount importance. Right, so we've done natural water, water rivers, multi-polygon with islets. I'm not going to go any further. We're running out of time and we need you to ask any questions. So I'm just going to end it here. We should deal with this a lot more in a more advanced section. Thank you, everyone, and I will pass it back to Geoffrey, who's going to just end off the last part. Let's just see if I can stop sharing. Okay, back to Geoffrey.
Yeah, thank you very much, Ralph. That was really awesome to see. And I think it just stresses the importance that when mapping waterways, we have to be extra careful. So I'll just go ahead and share my screen to go through the last part of our webinar, but I'll try to be fast so that we also spare some time for questions. So I'm just going to quickly talk about your lakes, ponds, reservoirs, and also swimming pools. So first of all, lakes. Lakes I think are really significant in OpenStreetMap. Like these are natural or semi-natural bodies, relatively still water. They can also be bodies of salt water, but they are always localized in a basin that is always surrounded by land. And the tags that we normally use to map lakes is water equals lake, and then you have to combine that with natural equals water. So basically what you'll do is to trace the outline of the lake, and then you add these two tags, water equals lake, and then natural equals water. But you should also be observant that there are also lakes which are artificial. So artificially created lakes, this should be tagged as water equals basin, water equals reservoir, or water equals pond. So these would be the artificially created lakes. These are the tags we would use for artificial lakes. But also, like I mentioned previously, for rivers, also we have like additional tags that we use on lakes. So yeah, the one that should not miss would also be the name of the lake, and that would be the officially designated names. Now, the good thing with OpenStreetMap is also it allows you to add names in other languages. So you may have a lake, but this lake has different names in different languages. So you can also add like always a name in a different language. We also have lakes which disappear and appear seasonally. So yeah, if that lake has that kind of behavior, then you would tag it, you love it as intermittent, yes. So yeah, and of course, you may also want to specify if the water in the lake is salty. So yeah, if it's a salt lake, then you would say you add that tag of salt equals yes. So yeah, those are the tags we use for lakes. And now moving on to ponds. Yeah, what is the difference between a lake and a pond? So a pond would be smaller, and in many cases it is man-made. But yeah, the obvious kind of difference is that it is smaller, far much smaller than a lake. So the tags we use for ponds are natural equals water, and also we have water equals pond. So those two tags, we combine them to map a pond. So if you just use one of these two without the other, the rendering on OpenStreetMap will not be correct. So you need to add these two tags to be able to render, for the map to render correctly. And of course, the additional tags, if the pond has a name, you can add it. And also if it is intermittent, also you add the intermittent equals yes tag. We also have reservoirs. So reservoirs are most commonly in large natural or artificial lakes, or you can call them, they're quoted using a dam to store water. So normally these ones you always find them, you find reservoirs where there are dams, like the picture that we see in here. This is a dam at the front here, but then at the back there is a reservoir, which is a large body of water which has been formed. So the way we don't tag these as lakes, because it's not, yes, it's a big body of water, but it's not a lake. It's actually a reservoir. So the tags used for that would be natural equals water, and then water equals reservoir. But for the dam, which is actually on the reservoir, we would tag that as waterway equals dam. The additional tags we would use on a reservoir would be, of course, the name of the reservoir if it has a name, intermittent, yes, if it is seasonal, and it, yeah. So it would say intermittent yes to indicate whether the reservoir permanently contains water or not. And also would use seasonal yes to indicate that it depends on seasonal conditions. Some reservoirs may be there may be swimming allowed. I think this is also like a very important tag to add. So yeah, swimming will be yes or no if swimming is allowed at a particular location of the reservoir. So that is reservoir. And then we also have swimming pools. So swimming pools, these are, waterways which are built for swimming. Most of the time it's for recreational purposes. Sometimes it's for like sports activities. So basically someone has excavated a piece, an area and filled it with water to form a pool. And the tag we normally use for swimming pools is leisure equals swimming pool. So you may find sometimes that you have a big facility which contains more than one swimming pool. So you cannot tag the whole facility as leisure swimming pool. No, then you just tag the facility as leisure equals sports center with an additional tag, which is sport equals swimming, meaning that this is a sports center, but inside the sports center, there is several, there is swimming. So several swimming pools within that sports center. But also you may find like just one big building, which has one single swimming pool inside. So you would tag that as leisure equals sports hall with an additional tag, which is sport equals swimming. So that is if it is a single pool. But for swimming pools, it would be really useful to add some additional tags, which would make it more meaningful and useful for the person that is using the map. I think one of them that is very, very important is whether is the access. So is the access private or public? So if it is public, yes, then you just add access equals yes, meaning there is public access. But if it is private, then access will be private. You may also want to specify whether, there is a fee charged. So yes, it may be publicly accessible, but do they charge or not? So if they charge fees, the answer would be yes. If there is no fees charged to access the pool, the answer would be no. You may also want to add swimming pools where like swimming is done as a sport. So that is the one which I had said, like it's a big building with several swimming pools inside, or it is one building with a pool inside, but it's usually used for sports. So then you would say, yeah, sports equals swimming. That is the tag that you'd add. The other useful tag that you'd add when mapping a swimming pool is the length of the pool. Is it 100 meters? Is it 50 meters? This is still, again, useful information for people who are, accessing this information to know how long the pool is. You may also want to add the location. Is it outdoor, indoor, or it is actually on a roof? You may want also to specify the depth of the swimming pool. So remember, swimming pools normally have like the shallow end and then the deep end. So yeah, that's when now you specify what is the minimum depth. So we use this tag, which is MIN depth, for the minimum depth of the pool, and then maximum depth, we use max depth to indicate what is the depth of the pool at the deep end. Yeah, in countries where there is like extremely cold weather, some pools are heated. So yeah, you may use that heating yes tag to indicate that there is actually heated swimming pool. Also, for where there is no heating, you may want to say heating equals no to specify whether there is heating or not. Some swimming pools have lifeguards, others don't have lifeguards. So yeah, if there is a lifeguard, you may want to say lifeguard equals yes. If there is no lifeguard, then you'd say lifeguard equals no to indicate whether there is a lifeguard present at that swimming pool. Adding this extra tag will help save lives. So yeah, you are mapping in OpenStreetMap, but also you are making people safer as they use these facilities. And of course, the last one is to indicate whether the pool is having fresh or salt water. So salt, yes, to mean salt water, and salt, no, to mean fresh water. So those are the additional tags that you would use for a swimming pool. But let me just quickly switch to my JSON now in about 2-3 minutes to show you. So yeah, I'm just going to focus on Uganda. This is where I am based, but you can see this place has very many lakes. It's called the Great Lakes region. It also has like this big lake, which is Lake Victoria. So yeah, starting with that, maybe how do you, of course, I think when you are trying to map lakes, the chances are that you'll find almost all the big lakes are already mapped. So it's not like on every day that you'd find like a lake which is not yet mapped. But the good thing is that you can add additional tags that would make the information useful. One thing that I want to point out is that when we're mapping lakes, we sometimes map them as, like Raf mentioned, as also multi-polygons, because they have like islands in them. And also some of them, like you may, for example, find like the line maybe for the lake is actually also like a borderline, things like that. So yeah, sometimes lakes are also mapped as multi-polygons. So for example, if I just select this, let me just add some filters to make sure this is not loading lots of data. All right, so I'm just going to select Lake Victoria, and then you'll see how it is tagged. You realize that it is tagged as a multi-polygon, but also you'll realize that yeah, it's like a relation. So several things like attached to each other. So that's why it's very, very important to be careful when mapping this, because if you break the relation, the lake will affect the lake. Yeah, there is one time when I went to OpenStreetMap and I found Lake Victoria. This big lake had disappeared from the map. And this was because someone was mapping a road nearby which was like going through one of the boundaries of the lake, and actually deleted that part of the segment, and yeah, the whole kind of map polygon also kind of disappeared. Anyway, so you can see here, this Lake Victoria is is a multi-polygon, and it has 1,729 members. So it's kind of like really a big object within the database. And I can see here the inner and the outer, but also I can see the tags that have been added here to map this really big lake. Okay, so I just wanted to point out that yeah, sometimes if it's a really, really, really big lake, it will be tagged as a multi-polygon. It may also be tagged as a relation. So we should be careful when trying to look at that. I'm also going to show just a very quick example here of a reservoir. And like I said, reservoirs sometimes are found near where there is a dam. So there is a reservoir here, which is in Uganda. So let me just put the imagery here. So as you can see, this is the reservoir here, and it has been formed because there was a river, and on that river, a dam has been created. So the water that is being held back by the dam forms a reservoir. Again, this reservoir has already been mapped in OpenStreetMap, and I can select it here, and then you can see where the tag. So maybe it wasn't actually. Just want to check the tags. I don't see the tag here for the reservoir, but yeah, it's a reservoir. It has been. It is on River Nile, but there is a dam, and it has formed a reservoir. The other one that we talked about was a pond. There is a pond here which has not yet been mapped. So just to show you how I would map a pond, still I will just get my draw tool and just draw around the pond. So yeah, you can see it is it's a small body of water. It's not as big as a lake, but yeah, it is a pond. So basically what I would do is to draw, and after drawing, then I'll add my tags to indicate that this is actually a pond. So the two tags that I'll add, one is going to be natural water. Natural equals water, so I've added that tag. And then I'm also going to add the water and then pond tag to indicate that this is actually a pond. So these are the two tags I've added after drawing my pond. I would have added the name of the pond if I know it. But yeah, if you don't know the name, don't guess the name, just leave it empty. Maybe another mapper who is from this area will find the pond that you have added. If they know the name, then they'll add. And that's the beauty of OpenStreetMap. It's all about collaboration and people adding different things. I'll also show us maybe one example of a swimming pool, and then I will try to end there. So let me just find a swimming pool here. So I've added like these filters, which help me to find things very easily when I'm looking at the map. So yeah, I can see some swimming pools here after adding the filter. And if I select this, I can see the tags. So as you can see, someone has tagged this already as leisure swimming pool. But yeah, maybe the access tags could be added. So these additional tags that I added, especially if it is a public pool, it would be good to specify whether it is publicly accessible, whether there are fees charged, what is the deep end, like what's the maximum depth, what's the minimum depth, what is the is there a lifeguard or no lifeguard? So those useful other additional tags can be added to make the data actually more useful. And I think these are things which can be added now by local edits, people who live in this area or someone who's close to the facility. You have visited this facility, you have visited the swimming pool, and yeah, you use your whether JOSM or use another tool to add these extra tags. So yeah, that's a little bit about lakes, ponds, and reservoirs, as well as swimming pools. I'll stop sharing my screen here and hand over back to Michael to facilitate the QA if there are any questions. Thank you.
Okay, so thanks, Jeffrey. And while I'm going to show you our final slide, Jeffrey, you might want to have a look at the chat window. There is a question specifically for you. And yeah, so first of all, you might have questions after this meeting. That's pretty clear. So therefore, you're not lost. There are several ways to contact us. You can write a mail either directly to the Mapper Support hotline, or for more general questions about our working group, we've got an email address as well. Our main communications channel usually is Slack. If you don't know that, point your browser to slack.hotosm.org, ask a few questions, and you will be provided an access link. And then you're in the general channel. And then you can, for instance, look for the Mapper Support channel or simply explore all those channels. And the humanitarian OpenStreetMap team, of course, has a website where you can learn more about what we are doing. Yes, there have always been 70 to 80 participants in this meeting. This might even be a new record. Thank you. That really lets us know that this topic is of interest, and there was also a pretty lively discussion. All that, of course, motivates us to do more. So I'm pretty sure that you will hear from us next year, and we will get back to you with more webinars. So unless we do have some unanswered questions here. Yeah, as I said, I also shared the link, and I can do this again now. This is the link to the Humanitarian OpenStreetMap Training Working Group's playlist on YouTube, where all our webinars are, our recorded webinars are presented. Give us one day or the other before processing is completed, and then, of course, this webinar will be available there as well. And so, thank you, the audience, for your presence and for your questions. Thanks go, of course, to my fellow contributors here, Jeffrey and Ralph. And I think with that, and with being nearly on time, I guess, yeah, I think we can end this webinar unless yeah, there seem to be no further last minute questions here. So thanks for joining. The recording should have ended, I guess. And yeah, hope to see you at another